Hello everyone. Continuity and differentiability from graph. Topic is nothing new over there. But today's class I want to compare continuity and differentiability from theoretical point of view as well as from graphical point of view. I'll give more importance to graphical method for all exams including your board, JEE, ISI, CMI, whatever exam you are going for, graphical method plays a very important role to decide continuity and differentiability of a function. For a continuous function, you can define it the function whose graph can be drawn without any break, without lifting your pen or pencil. This is meaning of continuity. Continuity means continuity of its graph. On the other hand, differentiability. A function will be differentiable at a point if the function has unique value of differentiation over there. If differentiation, left hand derivative and right hand derivative gives a different result, then the function will not be differentiable there. It means if the graph of function at a point has a kink, has a corner point, very sharp edge, it won't be differentiable over there. Let me illustrate with some simple example in today's class. If I draw the graph of function like this, between these 2 points the graph is continuous. You can draw the graph of the function without lifting your pen or pencil. Every point between A and B we are able to draw the graph of the function. No specific function I have taken. Continuity means we will be able to draw the graph or continuity of the graph of the function. But imagine there is a function given this manner. Is it continuous? No, it is not continuous, and this is a very important function which you have already learned. This is fx equal to mod x by x, that is called signum function. For x not equal to 0 and x equal to 0, it is 0. We have discussed continuity of this function in the previous session. This is not continuous at x equal to 0. Okay. Now, if you consider the graph of this function, in this example, I am drawing the graph of a function which is fx equal to 1 by x minus 3. Will I be able to draw the graph of the function everywhere? No. At x equal to 3, I won't be able to draw the graph of the function. X equal to 3 becomes vertical asymptote to the function, okay, at the point x equal to 3. X equal to 3 line exists, the graph also exists, but you cannot draw the graph of the function without lifting your pen or pencil. This function, it is not continuous. It is not continuous at x equal to 3. How have we got this graph? You got the graph of fx equal to 1 by x and shift it towards right by 3 unit. All these things you have done in class 11 mathematics. You can go through my videos, or the way you have learned, it's fine. This is just by shifting the graph of fx equal to 1 by x, by shifting the origin from x to 0 to 3, we get the graph of this function. All those concepts when you are discussing continuity and differentiability by using graph, all class 11 whatever graphical method you have done plotting the graphs of functions is required here, at least for today's class. If x equal to modulo x, I mean if this function is not continuous at the integral points at x equal to, I mean in this interval, x belongs to this interval, that -4, -3, -2, -1, 0, 1, 2, 3, like this. Because the graph of function, it is not continuous at those integral points. You might have seen before, the graph of the function will be like this. These are the points, or blank is there, the function will be discontinuous. This is 1, 2, 3, and this is -1, -2, -3, like this. Function is not continuous at the integral points. Okay. Now the graph of the function I have started with in the beginning by considering this. This is graph of fx equal to sine 1 by x. Graph is not very prominent over there, but x equal to 0, the graph of the function will not be continuous. Okay. And this is just meaning of continuity from graph. If we are able to draw the graph of the function, we can decide the function quickly. Okay. Now, concept of differentiability. What is that? That at the point x equal to a, it is limit h tending to 0, f of a plus h minus fa by h, and this must be also equal to limit h tending to 0, f of a minus h minus fa by minus h. In the first class on differentiability, we have stated this one as RH derivative, and this one we have defined as LH derivative, that left hand derivative. This we write L f dash t, R f dash t. But these are the values of derivatives only. On the right side, this is the value of derivative. I mean, this part is the slope of tangent. Okay, on the right side of the point x equal to a, and this one is what? The slope of tangent on the LHS of the point x equal to a. If these two have unique value, differentiability means they have a unique value which we define as f dash t, or the value of dy by dx at x equal to a. If they have unique value, then you say that the function is differentiable over there. Okay. If I draw the graph of a function like this, at every point, if you draw the tangent to the curve, the tangent has unique direction. Okay, any point you draw tangent you draw, this has unique tangent. Okay, so it will be differentiable everywhere. This is a graph of a, maybe the graph of polynomial function. This graph, this function is differentiable everywhere. But there is a problem when the graph of the function has a corner, sharp edge, like this. Fx equal to the function mod x. Fx equal to mod x function, it doesn't have unique tangent at x equal to 0. On right side, if you evaluate the value that fx is equal to x, you know, for x greater than 0, and fx equal to minus x for x less than 0. This is the function, no? Fx equal to mod x, that mod x will be what? Plus x for x greater than 0, minus x for x less than 0, 0 for x equal to 0. At 0 on RHS, what is the slope of the function? That you can get by direct differentiation. Okay. Normally for board's exam, we say that don't differentiate directly over there. But in any other exam, even when you are answering board MCQ, you go for differentiation straightforward. That if dash x has value 1 for x greater than 0, minus 1 for x less than 0, 0 for x equal to 0. So slope of this part is 1, slope of this part is minus 1. So at x equal to 0, L f dash 0, that is slope of tangent, is minus 1, R f dash 0 is plus 1. The function is not differentiable at x equal to 0. Isn't it? So this is a case of mod x. In any mod function, mod x minus 1, mod x minus 2, whatever you take, it will happen this way, right? So you more example. Now let us take another example here, that if x equal to, say I have given x cube for x less than 0 and x plus 2 for x greater than equal to 0. This function, if you check continuity at x equal to 0, what do you observe? For continuity at x equal to 0, limit x tending to 0 minus fx will be limit x tending to 0 x cube, 0 cube, this is 0, and limit x tending to 0 plus fx is what? This is limit x tending to 0 x plus 2. This is equal to 2. The function is not continuous at x equal to 0. And you have seen that differentiability ensures that the function was continuous. It was continuous. Okay. So differentiability ensures continuity of a function at a point. But continuous function, continuity never implies differentiability. This function is not don't say never imply, it implies, but not always. This function is not continuous only. If it is differentiable at a point, it must be continuous over there. It is not continuous only at that point. So the function is not differentiable at x equal to 0. But this kind of discussion we are not going to do today. Only just for comparison purpose I will be doing. I will show you this graph of the function helps a lot to understand the continuity and differentiability of the function. So let me draw the graph of the function here. X, y. This is a cubic polynomial graph. The graph of the function is like this, but up to 0 only. And this one, it is x plus 2. For 0 it is 2, isn't it? And the slope is 1. Because why slope is 1, that you know, because y equal to x plus 2. The graph is going to be like this. And this point is 0, 2. Are you able to draw the graph of this function without lifting your pen or pencil here? No. So the graph is not continuous. Now what is happening if we go for differentiability direct, not by knowing the continuity of this function? If we go by direct differentiation, that if dash x is 3x square for x less than 0 and it is 1 for x greater than or equal to 0. So if you write the value of a left dash 0, what is that? A left dash 0, you put x equal to 0 over there, 3 into 0 square, that is 0. And r left dash 0 is what? This is 1. See, these two are not same. If you draw the graph from there, it is not continuous, so it won't be differentiable. Confirm. And by actual calculation of derivative also, before x less than 0, after x equal to 0, the slopes of functions will not be the same. I mean, derivative of the function will not be the same. So the function is not differentiable at x equal to 0. Clear? Hope you have understood. Now let me go for this function, that fx equal to x to the power 1/3. Fx equal to x cube, graph we have seen, that is about x axis, it goes this manner, almost it goes this manner. And for fx equal to x to the power 1/3, this is for fx equal to x cube, and for fx equal to x to the power 1/3, the graph of the function is going to be like this. Okay, about the line y equal to x, it will be symmetric. Now this function fx equal to x to the power 1/3, is it continuous everywhere? If you draw a tangent over there, there will be a unique tangent. It is continuous, differentiable at x equal to 0. Confirm. Continuous and differentiable at x equal to 0. Both of these functions, both fx equal to x cube and fx equal to x to the power 1/3. First, the graph is continuous. Second, we get the unique tangent over there, it will be continuous. What about y equal to fx, that is equal to x to the power 2/3? This function is actually x to the power 1/3 square. Okay, so if you draw the graph of this function, the graph of the function going to be like this. This part will be as before, and if you replace x by minus x, the graph will remain the same. The graph is symmetrical about y-axis. Why? Because if you replace x by minus x, the graph will remain the same. The equation will remain the same. This is for y equal to x to the power 2/3. So at the point x equal to 0, it is continuous. It is continuous at x equal to 0. But if you try to draw tangent here at the origin, it will be like this, and tangent at this point, it will be like this. Okay, so there is no unique tangent at the point O. It has a sharp end at the point O, that is 0, 0. So it is not differentiable at x equal to 0, but it is not differentiable at x equal to 0. Okay, hope you have understood. Now let us go for the other kind of functions. The graphs of functions, I'll assume that already you have seen my videos or you have prepared on your own, and then you are doing this class, because graphs of function I'll be using here to understand continuity and differentiability. Next session, when I am going to discuss PYQ on continuity differentiability, you don't have any problem in understanding this. Let us decide continuity and differentiability of this function fx equal to mod of x square minus 3x plus 2. how to plot the graph of this function. The steps I just remind you, it was the graph of x square minus 3x plus 2 first. From there, we will be drawing mod of x square minus 3x plus 2. This on factorization will give you x minus 1. So, this function will be intersecting x axis at 2 points. That is x equal to 1, x equal to 2, this is 1, this is 2, and y axis also to intersect at 0, 2. So the graph of the function is going to be like this, almost. It continues both the way. Okay. So the coordinate of this point is going to be 1, 0, and this is 2, 0. You can see that this is x square minus 3x plus 2. This function is continuous everywhere. And when you are going to plot the graph of this function, mod of this, mod of x square minus 3x plus 2, what we have to do there, we have to remove the lower part and then take the mirror image about the x-axis. Okay? We have to remove, you draw this part first, no problem, you just remove this portion. So this is going to be the graph of fx equal to mod of x square minus 3x plus 2. It is continuous everywhere. Continuous on R. Because the graph continues, you will be able to plot the graph of this function without lifting your pen or pencil. Anywhere you just consider the case, you will not draw the graph lifting your pen or pencil. You can do it without lifting your pen or pencil. So it is continuous everywhere. But if you observe the slope of tangent in between 1 and 2 point, unique tangent everywhere. But at the point 1, sharp corner is there. So at this point, it is not differentiable here. Similarly, at the point 2, the slope of tangent has two values. One is this way, the other one this manner. So the function will not be differentiable. The function is not differentiable at x equal to 1 and x equal to 2. Clear? Hope you have understood. Let us practice a few more sums on it. Suppose you are going to decide the continuity and differentiability of the function log of mod x. Log of mod x graph you can draw easily if you know the graph of log x. Log x graph, you know, it will intersect the x-axis at 1, 0. Okay, this is y equal to log x for any base. We are taking e base. Okay, then how to get log of mod x graph? Log of mod x graph, I'll just remind you, if any portion is there on the left side of y-axis, you need to remove it. But there is no portion, luckily, on the left side of origin. So we'll be just taking the mirror image about the y-axis. So this point is 1, 0. This is minus 1, 0. And the graph is not continuous at x equal to 0. Similarly, it won't be not differentiable at x, because differentiable function everywhere continuous. If it is not continuous only, there is no chance of differentiability. At the point x equal to 0, dy by dx has value what? Which is undefined. 1/0 form. Isn't it? Because dy by dx is going to be equal to 1 by mod x. At x equal to 0, it is value 1/0 form. So not continuous at x equal to 0 and also not differentiable at x equal to 0. Clear? Now in this context only, I would like to tell you the continuity of mod of log x, mod of log of mod x function. Take this one. This one bit challenging to plot. We'll plot the graph of this function and then decide the continuity and differentiability of the function. That function y equal to log x, you must have seen y equal to log x, and we have just plotted the graph of y equal to log of mod x also. This point was 1 0 and this point was minus 1 0. Now for mod of log of, this is a graph of what? This is a graph of log of mod x, just we did in the previous example. If you want to plot the graph of mod of log of mod x, you take the mirror image of this part about x axis. The graph is going to be like this, and for this part won't be there, you have to remove this part. Similarly, you take the mirror image of this part about y axis and then delete this portion. Then you got the graph of y equal to log of y equal to mod of log of mod x. Okay, so obviously it is neither continuous, continuous everywhere except x equal to 0. Continuous everywhere except x equal to 0, because you cannot plot the graph without using or pen or pencil. But not differentiable at which point? At 0 derivative is not defined only. At minus 1 0 it has 2 derivatives. At 1 0 it has 2 derivatives. 2 tangents, 2 derivatives. So the graph it is not differentiable. It is not differentiable at x equal to minus 1, 0 and 1, although it is continuous over there. Isn't it? Now let us go for a few trigonometric functions. Say fx equal to mod sin x. Let us go for it first. Mod sin x, how to plot, you know that I am taking a small portion of the graph of sin x first. The same manner on left side also. Okay, this is the graph of y equal to sin x. Okay, now how to plot the graph of, this is y equal to sin x. How to plot the graph of y equal to mod sin x? You will be taking the mirror image of these parts about whatever this part is there will be there. Only you take mirror image of this portion about x axis and then delete the portion. This portion already there. Okay, it is already there in the graph. And on the left side you take mirror image of which portion? This portion. By taking the mirror image you got the graph here like this, and then this portion as before it continues, and this one again mirror image, again it's like that only. On both the sides it will be like this. Okay, so this graph, this is fx equal to sin x and this is fx equal to mod sin x. This function is not continuous, no, continuous everywhere. It is continuous everywhere on the normal line. Minus 2 pi, minus 3 pi, minus 4 pi. So continuous on R, but not differentiable at x equal to 0, plus minus pi, plus minus 2 pi, plus minus 3 pi and so on. Why? Because there won't be unique tangent over there. Okay, 2 tangents at x equal to pi. So this function is not differentiable at those points. Mod sin x not differentiable there. What about mod cos x? Cos x graph, you all know how to draw it. From there mod cos x also you can draw. The graph will be looking like this. I am just plotting the graph here. This is the graph of mod cos x. I have taken all the mirror images about the x axis for the function cos x. Then we are getting the graph of mod cos x. This is y x, and this is the graph of mod cos x. Here also you can see continuous on R, everywhere continuous, but not differentiable. Not differentiable when? Not differentiable for odd multiple of pi by 2 at 0, plus minus pi by 2, this pi by 2, minus pi by 2, 3 pi by 2, minus 3 pi by 2. So not differentiable at those points. Okay, this is the concept. Now what about sine mod x graph? Sine of mod x, is it continuous? Is it differentiable? You remember how to plot the sine of mod x graph? I just remind you again. Let me draw the sine x function graph first. On left side also same manner. Okay, this is the graph of y equal to sine x. For sine mod x, what you will do? For sine mod x, you will be removing the part on the left hand side. You will be taking on the right side part only. Okay? And then take mirror image of this portion about y-axis. This is the way we draw the graph of f of mod x from fx. This is the method, and this is going to be your this axis also you need to draw. Okay, so this function is not differentiable at x equal to 0. Continuous everywhere. 0, pi, 2 pi, in between any value, even minus pi, minus 2 pi, minus 3 pi, wherever you go, it is continuous. But not differentiable here. Not differentiable at x equal to 0. Because why? At x equal to 0, it has two different tangents. So not differentiable at x equal to 0. For cos of mod x, what happens? Cos of mod x, there is no problem. You draw the cos x function graph first. The cos x function graph you draw first. Like this. Then how to draw cos of mod x part? What you will do there first? You first remove the portion on the left side of origin. So what will be remaining there? This portion of the graph. This is your y-axis and this one x-axis. Now mod cos x graph to mod cos of mod x. How do you get? That you can get by taking the mirror image. But if you take the mirror image, do you find anything different? No. The same graph will be there only. That cos of mod x is continuous and differentiable everywhere. Clear? Hope you have understood. Now, what about these functions that just fx equal to say 3 minus mod of x minus 2. How to plot the graph of this function and decide continuity very first. I am not taking very complicated functions today. The functions which you can approach easily, I am taking that kind. So first you have to do mod x graph. Mod x graph you remember, we have just done. Then from mod x we will do mod x minus 2. We will be shifting the graph towards right by 2 unit. So this is the graph of mod x minus 2. Now you have to get minus of mod x minus 2. How to get that? You take the mirror image about x-axis. So this will be our just a minute. This will be our graph of mod of minus mod of x minus 2. Now, how to get the graph of 3 minus mod x minus 2? This graph will be shifting upward by 3 units. The same graph will be shifted upward by 3 units. If you shift it upward by 3 units, then you get the desired graph. Which graph? This one you are going to shift. If you shift in the graph of the function, this blue one will represent 3 minus mod x minus 2. Okay? Obviously, this graph is continuous, this function is continuous everywhere, continuous on R, but at this point at 2 equal to 0, at x equal to 2, it is not differentiable. Okay? So there is a sharp end, there is a corner, there is a kink to the graph at the point x equal to 2. So it won't be continuous over there. It won't be differentiable over there. Hope you have understood. Next session I am coming with PYQ on continuity and differentiability. Hope I will be able to explain with the simple concepts which you have learned in the previous sessions and today's session. Thank you.